last example that we did in lecture, and I promised that I would work it out in detail so everybody could see it. And what we have is these two charges hanging from, I don't know, some sort of roof or overhead line. It doesn't much matter, but they're hanging. And then you have this repulsive force between the two. So they are now static. Repulsive force going like that, keeping them both stationary and static. And we want to know what the charge is on Q. So if you're not my class and watching this just for entertainment value, what I would tell you to do right now is to go ahead and pause this, make a free body diagram and a summation of forces, and then come back and let's see how that went for you. Okay. I'm going to call this 1 and this 2. And I'm only going to focus on 1. Why? What do we know? If I know the force on 1, don't I also know the force on 2? So I only need to do it for 1. Just pick 1. I'm going to choose 1 because, I don't know, it's the force of 1. What do I have? Let's see. As far as my electrostatics go, they're the same sign, so they're being repulsed. So this is going to be my force 2 on 1. That's 1 force. It's suspended. And we know the mass of this thing. That's something I didn't write down. Where is it? That mass is 3.0 grams. And that theta is 20 degrees. Cool. So we know the mass on it. We definitely have a force of gravity acting. There is a mass, so force of gravity will happen. And then the last force is the tension force going up that line. So it's something like this. Force of tension. And what angle do I know? Well, if I draw this line straight down here, I know that this angle here is 20. So just like we were doing in the last example video, and in 161 are sum of forces in the x and the y. And I need to define, I'm going to say up and to the right is positive. So my sum of forces in the x, let's see, I have my x vector coming like this, and then my y vector coming like this for the tension component. So sine of 20 will give me the force of tension in the x direction. So force of tension sine 20. And that's positive. I've defined that in the positive direction, minus the force of 2 on 1. And that is all in the x direction, so I don't need any trig functions with that. And this is a direct sum of forces. We don't want just the charge for the electrostatic force. We want to do a complete sum of forces. So nothing is moving, everything is static. The sum of forces equals 0. Sum of forces in my y, well, let's see, what do I have? I have the force of tension component, and I have the force of gravity. So my force of tension component that's going up, it's going to be force of tension cosine of 20. And minus the force of gravity, and that equals 0. Let's leave things symbolically so we can make a really pretty equation in the end. Let's see. I have 2 equations, 2 unknowns, and the first thing I see is, well, I don't know the Q. So if I don't know Q, I can't solve for the force of tension. So my eyes immediately go to this one. I know the mass, so at least I can solve for the force of tension. So I can say then force of tension cosine of 20 equals the force of gravity. We know the mass. Or that my force of tension equals, I'm just going to write it as mg for the force of gravity. So in case you've forgotten, over the winter break, force of gravity is mg. So force of tension equals mg divided by cosine of 20. Now I can take this information and put it into here. So I'm going to get mg over cosine of 20 times sine of 20 equals, let's just go ahead and do our Coulomb force, KQQ. Q1, Q2 over R squared. Ooh, Q1 equals Q2, so I can simplify this to be mg. Actually, I'm going to simplify two things in one step. Sine over cosine, tangent, one trig function to put in your calculator instead of two. Tan theta equals kq squared over r squared. Cool. I want q. So all I need to do is move my radius and my k to the other side of the equation. Let me give us some more room here. So r squared times mass times the acceleration due to gravity times tan of theta divided by k gives me my q squared. I don't know where you're coming from. Q squared. All right, so the only thing we don't know to be able to button push is what the distance is. I can come back to this trig function, and I can look at this. I'm like, I need this side. So let's see, that's going to be the opposite side. So sine equals opposite over hypotenuse. Cool. So if knowing the hypotenuse is 1, so 1 times sine of theta will give me half of the distance between. So it'll give me 1/2 of, we'll call that L. How about that? I'll do capital L so it's clear. So then the total distance R is going to be 2 times sine of theta equals all of L, otherwise known as, I'm going to say L equals R. Cool. So now I can rewrite this even more. I can go R squared. Oops. That's not what I want. R squared is going to be 2 sine theta squared mg tan theta divided by k equals q squared. So taking the square root of the whole darn thing will give me my charge. Let's see, can I simplify this any more? And look at this, I have this term is going to be squared, so I might as well just pull that out because the square root of a square is just itself. So 2 sine theta times the square root of mg tan theta divided by k will be q. And that's about as pretty as I can make that expression. It's pretty nice. Now I just need to put in my values. So goes to 2 times sine of 20 and the square root of mass. Let's see, the mass is in grams. So there's 1,000 grams in a kilogram, so 10 to the negative 3 kilograms. So 3 times 10 to the negative 3. Remember, G is 9.8 times tan 20 divided by K, 8.99 times 10 to the 9. And we just throw that into our calculator, and we'll get that Q is, drum roll, and I get 746 nanocoulombs as my answer. And there you have it.